today's video. So just a little bit more about Kubernetes. I think really the best way of understanding it is to actually start working with it, but I'll give you a bit of background and then we'll go through the architecture of the application we're going to build in Kubernetes next, and that will introduce you to some of the terms and concepts. But again, actually working with this stuff is definitely the best way to learn about it. So it was built originally by Google. It's now in the public domain, or it's now open source, and it's maintained by the Cloud Native Foundation. Often referred to as K8s, simply because there's 8 letters in between the leading K and the trailing S. And I may write Kubernetes as K8s. I'll probably still say Kubernetes though. It's a container orchestrator, huge subject area. So again, in this video, we're going to learn enough to be dangerous. We're going to learn enough as developers to get started and run stuff in Kubernetes, and it will be a fully fledged microservices type deployment. But it is a massive area and we're really only scratching the surface of it. I like to think that there's 2 broad user profiles. Some people may disagree with this assessment, but I think of developers using Kubernetes. So for the most part, that's the audience I'm focused on in this video. As developers, we want to run stuff on Kubernetes, okay? And what sits beneath it and how it's set up, personally, I don't really care too much about that. That's for really, I think, the second kind of category of user, and that's like the DevOps engineer or the administrator or whatever you want to call them, because there is a lot of setup required, and it's people's entire roles just to run Kubernetes and keep it running, okay? I'm not too focused on that, and I'm certainly not going to go into that in today's video, because number one, I'm not really that interested. Number two, I don't know that much about it, to be honest with you. I just use Kubernetes as a platform, and that's what I'm focused on today. All right, so let's go through the architecture a bit. Now, when I'm talking about Kubernetes architecture, I'm not talking about the internal architecture of how the Kubernetes system is composed. Again, don't really care, to be honest with you. We'll cover bits of it as we move, maybe little bits of it as we move through the video, but I really don't care how it runs underneath. It's not that interesting to me. I'm talking about how things run on top of it. That's really what I'm referring to as the architecture that we are going to build out throughout the rest of this video. That being said though, I have provided a very, very simplified view of how it kind of runs on top of my local machine in this instance, and how it would run theoretically on something more complex like a cloud environment, something like that, just to give you that context. All right, so let's get started there. So in our case, and I'm sure in your case as well, you're running this on a PC or a laptop or something like that. So I have my bare metal PC on that. I'm running Windows 10 Pro. And just out of interest, I'm also running the Windows subsystem for Linux, which is basically like Linux running on a Windows machine. And the reason I'm running that, a couple of reasons, but the main reason is actually when I run Docker, Docker actually uses the Windows subsystem for Linux to run containers effectively. It uses that part of the system to do that. It doesn't have to. If you're running Windows 10 Pro, you can use the Windows containerization platform. Can't remember what it's called, but you can use that. That's not available in Windows 10 Home. You have to go down the WSL2 route, but I've gone down that anyway because I think it's actually a nicer option, to be honest with you. So again, got your hardware. In our case, it's just a PC. You got your operating system, in my case, Windows 10, and then you got your container runtime, in our case, Docker. And then, not strictly correct, but I'm just saying Kubernetes then runs on top of that. So Kubernetes is this platform on which we can build stuff. And again, I'm not going to delve into how Kubernetes is architected internally. Not too bothered about that. We'll touch on some concepts, as I said. Now, this is really where we come on to talking about the architecture of the application that we are going to build. Now, one point I'll make here is there's a lot of information on this screen, and I do not expect any of you, if this is the first time you've used Kubernetes, to memorize this now and need to, memorize it going into the next section. That's not the reason I'm giving you this information now. The reason I'm giving it to you now is, number one, to start to familiarize you with some of the concepts, not asking you to memorize it. Number two, to give you an end state, because one of the things I found quite overwhelming when I was learning Kubernetes for the first time was all these concepts just kept getting thrown at me. And just when I thought I'd got a handle on it, more stuff kept getting thrown at me. And I was like, oh my God, there's never an end to this. And so the reason I'm giving you the end state architecture is so that you have that end view, that you know that we're working towards an end goal and we can kind of tick off our progress as we move throughout the video. And so we will keep referring to this architecture as we build it up throughout the video so we can see what progress we're making. And in that way, I think you'll kind of understand, number one, the concepts, and number two, that you are making progress and that there is an end in sight. So the first kind of high level object, let's call it that, is this term cluster. So this is a Kubernetes terminology now, and this is kind of what we're going to start focusing on. Docker Desktop is a single cluster system, okay? And multi-cluster systems obviously do exist, but they are kind of quite heavy going. They are like full-on enterprise type setups. We're definitely not going to touch that. I'm definitely not going to touch that. But from our purposes, we're running on a single cluster, and that is Docker Desktop. A little bit more digestible then is this term a node. And again, Docker Desktop, single cluster, single node. And those two terms, I might even do it myself, they kind of almost get used synonymously, not technically correct. Cluster, node. And so within one cluster, you can have multiple nodes running. And for example, if you, I did think about developing this video on something like Google Cloud or Azure. You're probably going to be running on a single cluster, but certainly in the case of Google Cloud, you would be running in a kind of multi-node environment. But again, not really that relevant to the video today. So Docker Desktop, single cluster, single node, okay? But you can have multi-nodes, obviously. Now we're going to start to delve into really what we are building out. We don't have to set up a node, we don't have to set up a cluster, it's just there, okay? That is already there. The fact that we have Kubernetes running, we have a cluster, we have a node. We don't have to do anything with these. And so, to be honest with you, going forward, not really going to refer to them too much after this, so you can kind of almost, not ignore it, but just kind of put it to the back for the moment, okay? But with inside our node, this is really what we are going to be standing up and running. So the first concept, really, that you're going to have to get your head around, and it's not that complex to be honest with you, is this idea of a pod. Now, what is a pod? A pod runs containers. So, as in the last section when we're running up containers at the command line, a pod is used to host and run containers. Now, a pod, a single pod, can run multiple containers. In this video, we're not doing that. It's one pod, one container, okay? Now, a container and a pod are different things, but for the purposes of this video, you could almost use those terms interchangeably. Not technically correct, but I'll forgive you if you do that, and I might do it myself. So pod, container, one-to-one mapping in this case. However, in the real world, you can have multiple containers running in a pod, but we're not doing that today. All right, so the first thing we're going to do is actually take our platform service image and run it in Kubernetes in a pod. First thing we're going to do, and we're going to do that using something called a deployment, but that's for later, okay? So pod is the first level object that we are going to start working with. Now, in the same way as with Docker, we can't actually access that running container now. It's not accessible from within Kubernetes. So what we're going to do next is set up something called a node port. And a node port is what's termed a Kubernetes service. And there's a number of services we're going to work with throughout the rest of the video. Node port is the first one. Node ports are really used only for development purposes. You wouldn't use a node port in a production type environment. So it's really just to allow us to test and get access to our pods, okay, and our containers as well. So it will give us Kubernetes will give us an external port that we will use. It will more than likely begin with it. In fact, it will begin with a 3, and it's usually a 5-digit port number, semi-randomly assigned. Think of it almost like the port 8080 that we used in the Docker example. We'll also have the port mapping, the internal port mapping, in this case, port 80. So external traffic will come in, and it will hit directly our port 80 of our running container in our pod. And it means we can test to make sure that it's all up and running. It's running okay in Kubernetes, and we can access it. So that's the first thing we're going to do. Next thing we're going to do is set up another pod with our command service running in it. Now, obviously, we're going to have to write our command service. That doesn't exist yet, but we're going to write that, build it as an image, push up to Docker Hub, and put it into a pod running in Kubernetes. In order for these two pods to talk to each other, they need to get what's called a cluster IP service. And you can see on here, you have your pod, and then you'll have a cluster IP service for each of the pods that need to communicate to each other. And again, there's this kind of concept of a port mapping, and that will allow our platform service to talk to our command service and vice versa. Next thing we're going to do, the node port, as I said, is really only used in a development context. In production, you would not use a node port. So what we're going to do next is set up yet another pod with something called an ingress Nginx controller. I know, as it says, an Ingress Nginx container, but it's really an Ingress Nginx controller running as a container. And what that basically is, it's almost like an API type gateway. So I have done a video previously on Envoy as an API gateway. Nginx is on a competing kind of platform that does a similar thing. And we're going to use that in this case to basically act as a gateway for our two services. It's going to run in its own pod. It's going to work in conjunction with something called an Ingress Nginx load balancer. Okay, and that's another service. And so external traffic will come in via the load balancer. It will talk to our Ingress Nginx controller, and the Ingress Nginx controller will route directly to our two services. Okay, it won't actually make use of the cluster IP services. They are really just used generally for container to container communication. The Ingress Nginx controller in this case is going to reach out directly to our services. Next thing we're going to do is set up a database, a SQL Server database, because at the moment we're running internal in-memory databases for both our services. So we're going to stand up a separate SQL Server just for use by our platform service. And it's going to have a cluster IP as well, so it can talk to the other services. The other thing it's going to have is access to persistent storage space, because our platform and command services, they can reboot, they don't need to store data, they're stateless. That's fine. SQL Server, it's a database, obviously it can't be stateless, it needs to store data somewhere. So we're going to use something called persistent volume claim to claim some storage on our physical disk. Now that area is starting to go into the domain of the DevOps type guys, the administrator type guys. It's not strictly developer area. Persistent volume claims, that's fine, that's a developer realm, but when you start going further down the food chain and you start talking about persistent volumes and storage classes and then setting up storage, that's starting to go into the realms of the DevOps type guys. Fortunately for us, we can just set up a persistent volume claim and that will do what we need it to do. And it kind of reaches down onto a physical disk. The final pod we're going to set up is our RabbitMQ message bus. And again, cluster IP, and it will allow us to talk to all the pods to talk together within our node. Now, one thing you'll notice here, you'll probably go, where is the SQL Server for our command service? In this video, just for the purposes of saving some time, the command service is going to have its own database, but we're just going to keep it as the in-memory database. Still has its own database, can't stress that enough. It's not using the same database as the platform service, using its own database. We're just going to keep it in memory. And maybe as a bit of homework, once you start to get familiar, you can spin up a second SQL Server just for it. But again, main takeaway, it's not got a SQL Server, but it still has its own data store. Very, very important. And then these cluster IPs, maybe not the best diagram. Basically, it's not saying that the platform SQL Server just talks to the RabbitMQ database, blah, blah, blah. It basically means all these four things can talk together. Okay, they're all chained together, they all talk together. Maybe not the best diagram. But yes, this is our end state. This is what we're going to set up. This is what we're going to build. And as we move through the rest of the video, we're going to refer back to this time and time again to make sure that we are making progress. So with that, I think enough theory. We're now going to move on to creating our first pod in the next section. All right, so back over on our application, just make sure you don't have anything running. And what we're actually going to do is we're going to move out of just working within the platform service project, and we're going to basically work within a kind of more, I suppose you'd call it a solution type context rather than just a project context. So in your command line, if you just come out of the platform service, and so we'll do a directory listing and you'll see that we have the platform service there. And I'm just going to come up one more level and do a listing. Now, all my solution is going to be within this E3 folder here. So what I'm going to do is type code R-E3, and that's going to reopen Visual Studio Code. And we've still got a platform service here. You can see everything in here, but we're now going to create another kind of project level folder. I'll just say yes to that. All right, and that's going to contain our Kubernetes assets, mainly our deployment files. So when you're working with Kubernetes, there's a number of ways you can set things up. You can run things at the command line to deploy deploy pods and do all that kind of stuff, or you can write files, deployment files. And that's the approach we're going to take because it's much more reusable than doing stuff at the command line. So in our, excuse me, in our solution context now, we're going to create a new folder. And I'm just going to call it K8s. Now, as I said in the previous section, K8s is really just related to the Kubernetes stuff that we're going to be writing. So it's not a .NET project or anything like that. It's just going to be a bunch of deployment files. So the first thing, as per our diagram, and if we maybe just pay it a little visit again, if we come back over here, I'll just bring it back up on screen. I'll need to get a more static version of this. Yeah, the first thing we're going to do, actually, yeah, that's actually working okay, is deploy a pod with our platform service in it. That's what we're going to do next, and then we'll come on and do the node port. But for now, that's what we're going to do. So within our K8s folder, right-click, new file, and we're going to create a deployment file for our platform service. So we're going to call this platforms-depl.yaml. Okay, so it's a YAML file, as the name would suggest, and depl obviously is just short for deployment. All right, so I think probably the best way to approach this is just to start typing it out and trying it as best I can to explain it as I go through. It's a bit long-winded, and there seems to be, you'll probably think there's a bit of repetition in this file, but everything is necessary, unfortunately, and YAML files, yes, are white space sensitive, so just be careful as you work through them. But if you follow along, should be okay. And remember, the code is on GitHub, so you can pull down this file if you do run into problems following along yourself. So the first thing we specify is an API version. So colon and it's apps /v1, and that's just specifying, yeah, the API version that this deployment file is going to use. Under the covers, Kubernetes actually works with basically a REST API essentially to create and destroy its own resources. So that's basically what we're specifying there. What kind is it? Well, it's going to be a deployment. So again, we're deploying something into Kubernetes, and as we work through the course, we'll have different kinds of these files. I don't want to populate it with all that stuff. Next thing is metadata, and we give it a name, and this is really just the name of our deployment. Okay, so we're going to call it platforms-depl for our deployment, basically. And then we come on to our specification, and this is really where we specify our pod effectively. So tab in, and the first thing we're going to specify is the number of replicas. Now, as I said when we were talking about Kubernetes, you can horizontally scale out the number of services that run. So we could have 3 instances of our platform service running if we wanted, and that's what's referred to as a replica. Here we're just going to have a single replica. We're just starting with one, at least to begin with. Now these next, there's going to be 2 bits that follow. Let me just type them out first, and then let me describe them, because they're a wee bit confusing, to be honest with you, but yeah, again, they're mandatory. So the first thing is a selector. And we come down and indent once again, and then we type in match labels, and it's actually getting some help with it, and then app, and we're going to call it platform service. And then we're going to back out again. We're going to stay within our spec, but we're going to be directly under our replicas and our selector tag now, and we're going to define a template. We're going to give it some metadata. Don't forget the colons, tab in. And again, you've got to be really careful with this white space here. And we're going to give it a label, or labels. And we're just going to give it a label of app, and again, platform service. We'll just select that from there, basically. Now these 2 things, the selector and the template, kind of work in combination with each other. And really what we're doing within this template, it's within here that we're really defining the pod and the container that we're going to use. And then this selector is basically selecting the template that we're creating. Okay, so it's a wee bit kind of convoluted, but this template stuff is where we're defining what we're deploying, and then the selector is basically selecting it for us as part of the deployment. And Then under there, we're going to back out to underneath metadata. So we're still within our template section, but directly under metadata now. And this is where we're going to define our spec. And under spec, tab in, and we're going to specify the containers that we want to run. And we're almost at the end, don't worry, we're almost getting there. And anything within YAML that has this kind of minus sign, that's an array. And you can even see by the name containers, it's plural. You could have multiple containers that we wanted to deploy. But in our case, we're just deploying one. We're going to give it a name of platform service. And what I want to do is just select this and make sure that we have these three things are called exactly the same thing. So the match label, the template app label, and the name of our container are all platform service. And then finally under here, just tab in under the name, we want to define the image. And this is just the Docker image for our service. So image : and then we just specify binary thistle / platforms service. And obviously make sure this name is the same name as the service that we have defined or you have defined. And again, remember, this will be your Docker Hub login ID. And we do actually want to specify latest here, okay? Now this complaining is just complaining about, we're not putting a couple of other things to do with resourcing limits. I'm not going to bother doing that, so I'm going to ignore that kind of warning. Now that's it. That's basically a deployment for a container into a pod, okay? So if you save that off, we'll find out if we have made any mistakes, but it looks okay for the moment. So again, probably for me, the most confusing thing is this selector thing, but really all it's doing is it's selecting this thing here that we've defined as part of our template. That's really all it's doing. Now we're going to come back in here a bit later and we're going to define our cluster IP service in here as well. If you remember from the previous architecture diagram, we're not going to put it in yet. We're going to do this all step by step, one step at a time. That's cool. So remember to save off, and yeah, now having defined our deployment file, we're going to actually effectively run it and deploy it into our Kubernetes cluster. All right, so back in our application, we are going to bring up a command prompt. Fantastic. Now, before we do anything else regarding our platform's deployment, what I want to do is just make sure that Kubernetes is running appropriately. Now, I believe I did anyway, bring over Docker Desktop, and I said to check that you have Kubernetes enabled and that it's got the little running instance down here. And that's looking all good. But one of the other things that we rely on as part of Kubernetes, and this is sort of starting to go into the architecture of Kubernetes itself, is basically the command line that we are going to use to drive all of this stuff. And the command line is kubectl, okay? And so if you type kubectl version, this is the command line tool we're going to basically use to issue all our commands. You will see, hopefully, if it's running correctly, you'll see a client version and a server version and all that kind of stuff. Doesn't really matter what the versioning is, just as long as you get something back. That means Kubernetes is up and running and the kubectl command line is all good to go. So let's clear the screen. And again, all these commands, or most of these commands, are in the cheat sheet that I talked about at the start of the video. So let's just do a directory listing where we are. We're in the, oh goodness sake, we are in, oh my goodness. We can see that we've got a platform service and we can see we've got a K8s folder. So we're going to change into our K8s folder and do a directory listing to make sure that you can see this platform's deployment file. And we're now going to apply that file. And so it's kubectl, apply, f, and then the name of the file. So this is platforms-depl.yaml. And if there's any issues with it, you'll get an error at this point in time, but that looks okay. So we've got a command that comes back saying deployment apps platform depl created. Okay, what does that mean? So if we do kubectl get deployments, because basically we've created a deployment. I'm going to spell kubectl wrong. There we go. You can see here that we have something called platforms depl, 0 containers ready or 0 pods ready, and 1 is up to date. So let's keep an eye on it. But the other thing you can do is see your pods running. So kubectl get pods. Now you're probably starting to see a bit of a pattern emerging here. With this command, you can use kubectl get whatever. So you can get deployments, you can get pods, you can get services. You can see here that we got one pod within our cluster now, and it's ready and it's running. So that looks good. Let's just get deployments again, and you can see now that 0, from 0 being ready to 1 being ready, it's all up and running. That looks really good. Okay, so I think if we come over to our Docker plugin, you can actually see here that we have a running container running in Docker, but isn't it supposed to be running in Kubernetes? Well, yes, obviously it is. Kubernetes is orchestrating it, but it still has to run in Docker. Now what I'm going to do is I'm actually just going to delete these two containers that we had created in the previous section because it's just going to get way too busy. All right. Now the other thing I want to do then is come over to our Docker desktop. And if you come over here, it's making itself rather big, and we just go into general. Actually, cancel out this. And we come over into the kind of main window. Actually, to be honest with you though, I actually find the Docker desktop interface can be a wee bit confusing sometimes. So if you go into settings, this is where our settings are, and you cancel to come out of that. This is kind of showing you running stuff. Now, the first thing you'll see is, well, wait a minute, there's actually two things running here. How is that possible? Well, this is a pattern that you'll see sort of time and time again. This is actually the running container. And this thing here, as you can see from the name, is actually the pod that's kind of running. So you can click on that, the actual container one, and you can look inside and you can see basically output from our service running in Kubernetes. And it looks very familiar. It's seeding data because we've got using an in-memory database. And you can see here, it's listening on port 80, which is basically what we saw when we ran it in Docker as well. All right, so that's all looking really good. So give yourself a round of applause. You've created your first deployment and you've deployed a service into Kubernetes, and it's running and waiting for us to start using it. Fantastic. So in the next section, what we're going to do a little bit more work here just to show you some of the things that Kubernetes can do and how it actually orchestrates services. And then we'll eventually come on to working with our node port. All right, so one of the things I want to show you, and it's one of the things that kind of confused me a little bit about the whole Kubernetes setup was, okay, what happens, and maybe this is my destructive nature, what happens, here's our running container here, what happens if I delete this? Okay, so let's stop it, and let's delete it. Let's remove it. What happens then? Anything. So if we come back to our command line, and we do, let's do up kubectl get pods, you can see that we've got our pod here, and it's saying 0 of 1 is ready. If we do it again, it's now saying 1 of 1 is ready, and you can see now that a container is running again. We come back over to Docker desktop. You can see that we have, the container has come back. We've stopped it, we've destroyed it, but it's just bounced back and come back up. How is that? Well, that is one of the whole points around the Kubernetes. It auto-recovers your containers for you. So if a container crashes, for example, something bad happens to it, because we've told Kubernetes as part of our deployment, come back to our file over here, and look at our deployment file. Because we've told it we want a deployment, we want one replica, Kubernetes is going to do everything in its power to ensure that there is one replica of our service running. So even though we explicitly destroyed it there, it still came back and runs again. So you can change that behavior if you want, but the whole point of Kubernetes is that you've told it to do something, you've given it the end state, it will make sure at all times that that end state that you've specified is being adhered to. So that's one of the very, very cool things about it. Now, that's not to say that you cannot destroy things, because that's kind of what I thought originally. You can. So again, if we come back to our command line, you can do something like kubectl. Actually, let's get our pods, get our deployments first. So kubectl, get deployments. And we have a list of deployments, and then we can go kubectl delete deployment and we'll take its name, and we will delete the deployment. Okay, do a up key, get deployments. There are no resources found. And if we come back over to our Docker desktop Kubernetes instance, you can see basically it has destroyed everything. We've destroyed the deployment, we've told it to delete the deployment, and there you go, it's taken everything down. All right, so just one other thing, just to show you how easy it is to tell Kubernetes to run 3 instances of our service. We can just change the number of replicas to 3, save that off, up key, and we'll go back to our apply command. So kubectl apply f platforms depl YAML, and we will hit enter. And clear the screen a wee bit here, and if we do kubectl get pods, you'll see that there are 3 pods. They're not started yet, but Kubernetes now is attempting to start 3 containers for us. And if we keep refreshing this, it will eventually, unless there's an error in our image, it will eventually reflect the fact that we have 3 running containers as part of our cluster. Okay, so you saw how easy that was. So again, the idea is if you're seeing high traffic on one particular service, you can quite easily spawn up 2, 3, 4, however many services, and you can deal with that increased demand. Of course, there are design considerations with the way you've built your service. There may be other things you have to consider, but in our case, it would literally be that easy. So you can see here, we've got 2 containers up and running, and this other one is in this container creating state. So it's still spinning up, and I'm sure eventually you will see all 3 will have started. So unfortunately for those 3 containers, there they are, they're all up and running, and we come back over to our Docker desktop view. You can see that we have our 3 services running, and then we have 3 associated pods, 1 for each platform. And that's a pattern that you're going to see time and time again. You're going to see these pods paired with a service. All right, so no sooner had we spun that up, I'm going to delete it because I don't want three services running. So we'll up key, and we'll delete deployments platforms depl, and then we'll do get deployments, kubectl get deployments. And we have no resources found, which is correct. And we'll just double check. Yes, it's in the process of deleting. That's cool. So I'm going to come back here before we move on, change that back to 1, save it off, and then for not for the last time, but the last time in this section, we're going to reapply our deployment and get our 1 service up and running. So that's all good. We have a service up and running, but we have no way of accessing it yet. So we're now going to create a node port that will actually give us access to see if we can query this service running in Kubernetes. So we'll do that next. All right, so we want to create a node port now, and a node port is one of a few different types of service that we can create. But just before we do that, just run a kubectl get pods, just to make sure that the pod that we kind of recreated, or the deployment that we reran in the last section with our 1 pod is now up and running. So we have 1 pod running, that's cool. So just make sure you do that before you go any further. So yeah, we want to create a node port now. So if we maybe just come back to our diagram, it's probably worth just taking a quick look. So we've done this now, well done. We're now going to create a node port, and that's going to allow us external access into our service. Now, you'll see on here, we are going to create a node port. We're going to specify this port here, which is just referred to as, you'll see in a minute in the file, the port, and this one here, this 80 is the target port. We don't specify this 30,000 port. Kubernetes does that for us. So we specify 2 ports, this one here and this one here. All right. So back over in our K8s folder, if you right click and do new file, I'm going to call this platforms np-srv, just to keep it kind of short. So .yaml, don't forget the YAML. So platforms node port dash service.yaml. All right, so I might just pull this down a little bit. And over in our folder, in our file, sorry, we're going to specify an API version again. This time it's just v1 as we're dealing with services. The kind this time is going to be a service. Whoop. We don't really want it to auto-complete it for us, so a service. Again, our deployment was a deployment type. This type is a service type. And we're going to specify some metadata. And this is really just the name that this service will be known as when we kind of work with it at the command line. So I'm just going to call it platform np service -srv. Okay, platform np service srv. Yeah, okay. Some of these names can get a bit unwieldy, so you have to be really careful that you type them in correctly. And then we specify a spec section, tab in, and the type, in this case, is node port. And then we're going to work with our selector. I'm going to specify the app. Now this is where we pop back over to our platform's deployment file and we pick this value here, platform service, okay? So it's basically, it's another selector, and this is what we are. We're selecting the same thing. Okay, this node port is going to be working with this platform service. It needs to know where to reach out to. And then we come back and then we specify the ports. So we're going to specify a name. From memory, the name thing is not mandatory, but I'm going to put it in anyway. I'm going to give it the same name as this. I think you need it if you're specifying more than one array of port types. And you can see here, this is an array that we're defining, or array element, should I say, that we're defining. So protocol is just TCP. Port is 80, and again, that's the port on the node port. And then target port is the target, it's the port of the service that we want to talk to. And that should be it. And again, yeah, if you were defining another, set of ports, then you actually do need the name in that case. If you're just defining one, I don't think you need the name, but we'll leave it in anyway. It makes for more descriptive reading anyway. Cool, so we'll save that off. Now, in a very similar way that we did with our deployment, all we need to do is do kubectl, apply, f, and then the name of our file. Now, actually, maybe before we do that, we'll just do well, I can see we're in the folder, but just do a directory listing to make sure that you're there. And yeah, let's go for it. kubectl, apply -f, and then it's just the name of the file that you want to apply. Great, and again, we can see we've got a service created. If you don't see this, you will obviously see an error. Again, the errors, I think, I've said this before, maybe I've not. If I haven't, the errors are quite good. They're quite descriptive. They usually get you to the root of the problem if you have made a mistake. So, although it said created, how do we know for sure that it's created? Well, you use kubectl again, get services, and you can see that we have two services here. Now, this one here was actually here by default. It's there already, so we can kind of leave that one for the moment. Don't need to worry too much about that. But this is the one that we have just created. So here's the name, as we specified up here in the metadata, and then you can see that it's a node port, and you can see port 80 is the internal port, and this is the port that we need to use to actually access the service externally. So let's move over to Insomnia again, and I'm going to create another top-level folder, this time for our Kubernetes environment. So a new folder, and I'm just going to call it K8s. Okay, so we've got one for local development, one for Docker, and one for K8s now. And then we're going to create another folder here for platforms, platform. Let's just keep it consistent. Platform service, let's rename that. Rename. Probably being a little bit pedantic, but want to keep it consistent, otherwise it can get a bit confusing. So platform service, and then we're just going to duplicate this one here. Okay, and we'll move it under here. But we don't want to use 8080, we want to use that other port that Kubernetes has given us or generated for us, so it's here. So if we just copy that, try that again, so it's 30, 40, 70. And we come over here and put that in here. And yeah, it all looks right. We query, there we go. We have access to our service running in Kubernetes, which I think is very, very cool. So give yourself a round of applause for that. We're making very, very good progress. So basically that is, well, that's not it. Obviously, we still have a long way to go, but let's refer back to our diagram to kind of check on progress. So we've now done this, that's fantastic. So really the next thing we want to do in the next section, we're going to concentrate, we're going to go back into writing .NET C# code, and we're going to construct up our command service, and then we're going to do a very similar thing and deploy it in here, and then we're going to get them talking to each other, and then it starts to become much more interesting, because then we're really going into microservices concepts. We talk about how these services can talk to each other synchronously or both. So yes. Next section we're going to move on to is to construct our command service. All right, so now what we're going to come on to do is create our command service in our kind of solution area. So back over in our, it's not really our project anymore, back over in our solution, just make sure you stop any running services. And let's close this stuff down as well. All right, so make sure that you are in the kind of top level of the solution. In fact, we're going to need a command line. So in the command line, just do a directory listing to make sure that you're in the top level solution area. You can see the platform service in K8's folders. And we're going to scaffold up a new service or commands service. So .NET new, so web API, and the name is command service. Hit enter, and that should go away and scaffold up our command service. Fantastic, and it appears here in our directory listing. So next thing we want to do, I'm just going to get rid of this, is bring up your CS proj file so you can see what package dependencies or package references we have in here, and we're going to add some more in a very similar way as we did with our other service or platform service. So .NET add package, and the first one, again, I'm going to just copy the first one. In fact, I'll probably copy most of them over. Save you watching me typing. Is Automapper. We're of course going to use Automapper here as well. So I think I must have done something wrong. Oh yes. So what I haven't done is change in to the project that we want to be working with. So CD into command service. There we go. So what it was complaining about there was I was trying to add a package reference, and it's complaining that there was no project file basically. So there we go, rookie mistake, and there we go. So we've got Automapper added into our CS proj file now. Fantastic. So we're going to add a few package references here. I'm not going to add all the packages that we need. I'll add the ones that we're going to need in the kind of near future. The ones that we'll work with a bit later down the line, I'll pull them in a bit later. So the next one is add package Microsoft Entity Framework Core. And just make sure it's added into the CS proj file. I'll do upkey, and then we need exactly the same, but this time design. And again, this is mostly the same. In fact, it's exactly the same as the platform service as well. Now, I did debate whether to just, skip this, not skip the section, but, not go through all the setup again. But I think it's good practice for you to go through the setup again anyway, and it kind of embeds what we need to do. And it is only one other service, so I think it's probably the right approach. And then we're going to add in memory. Now, as I said previously, I'm not going to work with a SQL Server database for this service, simply just to kind of reduce time a little bit. Working with an in-memory database is fine for the video. If you are moving into a more production environment, yes, you would use SQL Server. But for the moment, I'm just going to use in-memory. That's all. And that's it for the moment. We had the swashbuckle package reference in there. Again, that's for Open API. If I remember, we'll take a quick look at that. But that's it for now. So that's our package references done. Our project is scaffolded up. What I'll probably just do is just remove the stuff that we don't want. So the weather forecast service, we don't want that. And into our controller, we'll take out our controller as well. Whoops, we'll take that out as well. And we'll delete that. Now the other thing we'll actually do is over in properties, in launch settings JSON, if we spin this up, and we will actually spin this up locally, it's using the same ports as our command service 5000 and 5001. And so when we're doing some testing, before we deploy to Kubernetes or even package up in Docker, I'm going to run them both up locally and have them running at the same time, just using the .NET command line. And so obviously we'll get an error if they're both trying to launch on the same port. So I'm just going to change the command service ports, local ports, to 6000. All right, and what we might do, just to make sure it's all wired up correctly, is just do a .NET run, because you never know, there might be some little gremlin in the system that we didn't think about. And that all looks fine, and it's running on port 6000, 6001. It's not going to do much at the moment, because we've taken out our controller and we don't have any models or anything. All right, so we'll close that down. Now in the next section, what we're going to do, what I really want to focus in on, is we're going to create a controller first. We're not going to create models or anything like that. I'm just going to create a very simple controller with a very simple post action endpoint in it. And the point of that is I want to just get our two services talking to each other. That's really the next part of the video. We will eventually come back and we'll add models and we'll add all that kind of stuff in here. But for the moment, all I'm really wanting to do is get our two services talking synchronously to each other using HTTP. We'll do that locally and then we'll do it in Kubernetes. Okay, so that's really the path we're taking next. So in the next section, we're going to create a controller with one action in it that's going to receive a post request from somewhere else. And then we're going to get our platform service to talk to it in a synchronous way. All right, so we'll do that next. All right, so we're going to create a controller in our commands service, simply at this point, just to receive a post request from something else. In this case, it'll be our platform service, just sending something over to us, really just to test synchronous HTTP communications between the services locally, and then we'll do it in Kubernetes. All right, so back over here, I'm just going to close this down, close down the command line and close down launch settings JSON. And over in our command service, if you right click the controllers folder and new file, we're going to create a controller. Now this service is going to end up with two controllers. It's going to end up with a commands controller, as you'd probably expect, but it's also going to have a platforms controller. Why? Basically because this service is going to work with two models. It's going to work with commands and it's going to work with platforms. And the way I've architected this service, basically the platform is really the parent resource of the command resource. So if you think about it logically, you're going to have a list of commands like, you know, .NET run, .NET build. There'll be loads of those and they will relate just to one other resource, the platform. Okay, so when we are using REST, as we are here, to create resources such as platforms and commands, what we should really do is split those out into two different controller actions. So we will have a controller to deal with our platform stuff, very similar to a platform service, and we'll have a controller to deal with our command creation stuff. And you'll see how that unfolds a bit later, and I've got a whole section on sort of multi-model REST APIs. But for the moment, again, I just want to focus on getting some comms between the two services. So it might be sound a bit counterintuitive, but the first controller we're going to put in our command service is our platforms controller. Okay, so in controllers, create a file, platforms controller .cs. All right, fantastic. Now let's keep going, but I just want to call your attention to the fact that we are running VS Code with these three projects in here now, and that it can sometimes behave a little bit strangely, but let's see how we go. So namespace this time is going to be commands. Yeah, I think it's doing it already. Commands service. Yeah, and so we're not really getting auto completion at the moment. If you sort of see what's happening, usually if I started typing command service, I would get prompted with the full name of the service for our namespace. But let's it's very evident how reliant I am on it because I'm so used to that pattern. Let's keep going. Command service .controllers. Okay, and we'll just bring that onto the next line. Okay, and it's a public class. So public class platforms controller. And we're going to inherit from controller base. And we don't have that namespace, so control period. Now, this is what I'm talking about here. I'm doing control period to bring in my list of code suggestions, and nothing is happening, okay? And the reason for that, or I believe the reason for that, is because we're running VS Code, and we're now having it hosting multiple projects. So the kind of IntelliSense stuff appears not to really like that. So what we're probably going to have to do is close down our VS Code session running all these projects and reopen it just with command service, and I'm fairly sure then we'll get our code suggestions. So let me just save that off for the moment. Kill this. Actually, I won't kill it. I'll just bring up a command prompt, and then we'll come up a level, do a directory listing so we can see all our projects, and I'm just going to open code recursively, and I'm just going to open command service itself. Let's do that. Okay, fantastic. And if we come back over to our controller, there we go, it should start complaining, and I'm fairly sure if I put my cursor in there and do a control period, I will get my code suggestions again. So it's just something I've found. I'm not sure if there's any other way around it. There probably is, but for the moment, I'm fine with just running an individual project in our VS Code session. All right, so public class, platforms controller, inheriting from controller base. The next thing we want to do is decorate our class with API controller. As before, it gives us some nice default behaviors, and we're going to create a route again. Okay, so from memory from last time, API, and then you can either put in, not curly brackets, square brackets, you can put in controller. Okay, now you might see a problem straight away here, because we're going to have a route to something called API/platforms. We're also going to have that in our other controller as well. They may go, well, that's not a problem because the rest of the URL is going to be completely different. The IP address or the domain name is going to be different. Correct, that's fine. So we could leave this like this for the moment. However, when we come on to using our API gateway, things get a little bit more complex. So I'm just going to call that out now. I'm going to leave it like that at the moment. This will still work at the moment, but going forward, we are going to have to change this slightly to reflect that this is a slightly different platforms controller from the platforms controller in our other service. In fact, I'm going to put it in now, okay? Because if I forget when we run into issues, it might become a bit problematic. So what I'm going to do, and again, when we move through the rest of the video, this is all kind of hidden. Once we hide all this stuff behind an API gateway, this stuff is hidden. So you're not going to have these horrible URLs that you're going to have to deal with. But just for future proofing, I'm going to put this in. So all I'm doing here is the root is API, and then I'm going to specify that this C really is for our commands. This could be anything, by the way. I'm just putting C in. So API/C to denote our command service, and then the name of the controller. It'll become clearer later on when we move on to the gateway stuff. So bear with me on that. So that's our route. Fantastic. I'm going to create a shell constructor just so it's there, but we're not really going to put anything into it yet. Now we will eventually, like we did with the platform service, inject in automapper and a repository, but we're not doing that yet. Again, in this section, all we're interested in doing is getting an action up and running. All right, so leave a constructor like that for the moment, and then we're going to create our first test action. So it's public action result, and I'm just going to call it test inbound connection. Okay, and it's not going to accept anything really. And all we're going to do is just do a console write line, keep it really simple, bring in the namespace for console using system, console write line, and I'm just going to put something like inbound post at the commands service. Okay, so all we're doing, so we hit this action, we're going to get this printed out to the screen. And I just need to make this decorated with HTTP post. And then finally, you do need to return something back as it's an action result, so we'll just return OK. And I'll put something in here, I don't know, inbound test OK from platforms controller. Quite a few spelling mistakes in there. All right, fantastic. So that probably looks a little bit convoluted. I'll put the trailing semicolon in there, and maybe some of the stuff in here going, don't quite follow that. That's okay, don't worry, it will become a lot clearer later on. So what I want to do now is just test this, okay? I'm going to test it from Insomnia just to make sure everything's wired up correctly and it's working okay. So into the terminal, make sure you're in command service. We'll do a .NET run. I don't think I'm forgetting anything, but we'll find out. And it should be running again on port 6000. Fantastic. So let's bring up Insomnia, and we're going to close all that down, and we're going to come over to our local development environment, because that's what we're running in. We're going to create a folder under here, new folder, and we're going to call it command service. Okay, and we're going to create a new request. It's going to be a post request. We'll select JSON, and we might pass some JSON over eventually, and we're just going to call this test inbound connection. Okay, create. Fantastic. And what I might do is just come in here, and I'm just going to copy this. Make sure I copy it all. And I'm going to paste it in here. Make that a little bit bigger so you can see it. Now, a couple of things here. The port's going to be different, so it's going to be port 6000, and as per our route, it's going to be API/C platforms. Okay, so back over in our controller, you'll remember, this is the route to this controller. Okay, so API/C, and it'll be platforms, because we're in our platforms controller. All right, so again, screen's running at quite high magnification, so I'm just going to click send. We get a 200 OK, and we get the response back, inbound test from our platforms controller, which looks good. And if we come back over to our running service, you can see that we got this message printed on screen. Cool, so very simple, but really just setting this up to establish that we have an endpoint in our command service. What we need to do now is create a method of calling this from our platform service, so we have that degree of, so we can establish some communication service to service. We'll run that both locally, and then we'll deploy it into Kubernetes. So we'll move back over now to our platform service and write up what we're going to call a synchronous client, effectively, synchronous HTTP client. So we'll do that next. All right, now actually, before we move on to doing any coding, I do appreciate I've been talking about synchronous messaging and asynchronous messaging, and you might be going, what's this guy talking about? So yes, I think it's a good time to talk about this now. I was going to leave it till a bit later.